plan for today, we're supposed to finish 4.1 for sure, and start 4.2. Yeah, so 4.1 will be due. 4.1 will be due on Wednesday. Hopefully we'll get moving into 4.2. We're going to try to move quickly through Chapter 4 because I took an extra day on Chapter 3. So, what's today? Today's the 30th. Tomorrow's Halloween. So, schedule says we need an exam 2 weeks from today again. We'll see what we can do. All right, let's move ahead. So, law of sines. Remember the law of sines. It basically says sides and the sine of the angle opposite them have equal fraction ratios. What do I mean? Like little a over the sine of angle A is little b over the sine of angle B is side C over the sine of angle C, right? Side over angle, or side over sine of angle equals side over sine of angle, etc. So there's a consistent ratio. Fractions are equal when you take sides and the sine of the angle across from them. So it's really pretty easy. I think you'll find this section pretty easy. So when you're looking here and you say, all right, what do they want me to find? I don't even know what the question is. Okay, so they want side or angle C first off, and then little b and little c side. So they want angle C first off. So how do I find angle C, this angle up here, this opening right there? What do I do?
Subtract the other two angles from 180.
From 180, right? Because every triangle holds 180 degrees, doesn't it? So we just say, okay. So that's going to be what? 56 degrees and 38 degrees. Add them up. 94. And then take away from 180. That's going to leave what? 86 degrees. So angle C must be 86 degrees to make 180 in that triangle. Okay, good. Now, that was just total in a triangle. We didn't use the law of sines yet. Now, on part B, we're going to use the law of sines. How do we find the little b? How do we find the little b? The side. They want to know how long is that side, right? How long is that side? Well, here's where we use the law of sines. There's a connection between a side and the angle opposite and any other side and the angle opposite. So you can use whichever. I'll just use this pair, I guess. It doesn't matter. So you just kind of see how I'm just connecting them up? I'm just going to use a side and the sine of the angle opposite, and a side and the sine of the angle opposite. So let's do that. So I'm going to say little b, which is what I'm looking for, little b, over, go across here, the sine of 38 is equal to what? Little a, 109, over, go across from it, the sine of 56 degrees. Everybody seeing all that? So you just do a side and the angle opposite, a side and the angle opposite, like that. And there you have, and you just do two of the fractions, right? Even though the law of sines says the relationship is true for all three, we only use two at a time, huh? So I just use those two, and now I can solve for b, for the little b here. So how do you solve this equation for the little b? Cross multiply, right? When you get equal fractions, just go diagonal, diagonal, cross multiply. Little b sine 56 is 109 sine 38. That good? To there, just diagonal. Everybody see what I did? Right? Just diagonal, diagonal. Just multiply. And I'm trying to solve for the little b. So what do I do now to finish solving for the little b? Divide by that sine. 56. Boom. Hit the buttons on your calculator. I didn't bring mine. Somebody have that? What's 109 sine 38 over sine 56? Anybody got it? 80.9, thank you. Says round, or what does it say? Round to the 10th. Yes, that'd be to the 10th. Even once it says nearest 10th, so that's 1 decimal point. There we go. 80.9. Is that good? Maybe I better move it up here so there's room for the next one. 80.9. All right, can you guys do C now? So let's try to find side C. What was the angle? This angle was 86, wasn't it? 86 there. So how do you do side C? The same thing. So set up two fractions. So that would be little c over the sine of 86. Because that's the one I want, right? I want little c, so use those two for sure. Now what other two? Either one. It'll work the same either way. You could either do the little b. Well, you know what? I probably wouldn't use the little b. Why wouldn't I use the little b?
Accuracy.
What's that?
The accuracy.
Accuracy, because it's rounded, huh? That's right. Little b is a rounded number. You know, it really, you know, we just did it. It really goes on and on and on. And the problem is, with using a rounded number, it can throw off your final answer. So it's best not to use rounded number, to not round anything until the very end, or if you have a rounded number, not to use it. So I'm going to use these two. So I'll use 109 over sine 56. Everybody see that? Use those two instead. Because that way nothing's rounded. It's all real, reliable numbers, no rounded numbers. You know, it would be, if you wanted to use little b, it'd be okay, but you should use more accuracy. You know what I mean? You should like 2 or 3, because they want the final answer accurate to what decimal place, tenths place. So you better use stuff along the way that has more accuracy than that. So, either way. All right, diagonal, diagonal, c sine 56 is 109 sine 86, and then divide by the sine 56, like that, and we get an answer, which I don't know. Somebody get that?
131.2. Wait, how many decimal places?
Yeah, just one spot, 0.2?
Yeah, 0.2.
131.2? That good? Yeah.
Could we kind of skip a step if we just multiply by sine 86 over 1 instead of cosine?
Yeah, you could do that. That's a good idea. Yep, that'll work fine. Good. Questions on that then? Lost sign's not too bad, right? All right, I'll move on. So let's do that. Yeah, so they give us this setup. They tell me capital A is 102, capital C is 33, little c is 90, find other stuff. Yeah, so let's draw the triangle. And you can put them wherever. I'll just put A here and B here and C here. Doesn't matter, you know, where you put them. But it does matter. Once you've got the A, B, and C points in there, angles in there, it matters where you put the little sides, right? The little a side. Where does the little a side have to go? Across. It has to go right here, right? Across from the capital A angle. So they're just making sure you understand how they configure these triangles. They always do them that way. So the little a would be there, the little b would be here across from the capital B, and the little c side over here across from the capital C. We good there? So now, and then they tell me capital A is 102, capital C is 33. So can you find capital B and then little a? Give you a second there. Well, in fact, I think it'd be better if I go ... now, right? Well, good. The rest is the same. So once you've got the picture, same as the last problem. Is that okay that I just move on? You'd find little b, right? 102 plus 33 is something 135, and subtract from 180. 180 minus 135 is 45 degrees. Like that, 45 degrees for capital B, and then you can do all the rest. The same, use the law of sines and crank them out. All right, I'm going to move on. Okay, So first off, let's draw the picture that they're giving us here. So yeah, go ahead. Let me let you do that. So draw that triangle. Draw the triangle they're speaking of, and take a look at it. See if you can find capital B. So start off by finding capital B. Give you a second to do that. Then I'll jump in. Okay, so let me see how y'all are doing. Okay, keep going, fill in the information. Okay, so did you find capital B? So you have that picture, right? Is that good? Try to find capital B. So we'll say, what are we going to do? We want a connection between these two. Yeah, how do I know which two? Well, I want those two. Am I racing ahead of you? Okay, you get that picture? However, you might have the A, B, and C somewhere else, but as long as you have the A across from A, B across from B, C across from C, it's all good. So I want those two. How do I know? Well, because they're asking me for B in this question. They're asking me for capital B. So I've got to have a connection involving capital B, right? So I got to have the BB connection. And then what's the other connection I'm going to bring in? I've got the BB connection. What's the other one? Yeah, I'm not going to do CC because I don't know either. I don't know anything about C. So that won't help. I'm going to use these two. You with me? Wendy?
There's a formula you go through.
Yeah, we'll get there. So go ahead and set that up first off. So just set up the law of sines there. So set up the law of sines. Let me let you finish that. So find capital B there. So yeah, is that confusing? So we're going to say little a, which is 10, over the sine of 80. So like that, right? Is little b, the 9, over the sine of capital B. And I don't know what that angle is. I don't know what that angle is. So I'm going to try to figure it out. So keep going. Solve that. You can use your calculator, right? Solve that. Do the cross multiply. Solve for capital B there. Okay, so let's do that. Diagonal, diagonal. So we get 10 sine B is 9 sine 80. Good to there so far? Just diagonal, diagonal. All is good. And then how do we finish solving for the b divided by the 10. So we get sine of b is, somebody have that in their calculator? I should have brought my calculator today. Here, go ahead.
I got 0.886.
So go ahead and finish getting b with sine inverse. Okay, so when you get all that, so I'm getting 9, what mode am I in? First degree, yeah. So 9 sine 80 divided by 10. So I'm getting this equals 0.886 327. So then you hit sine, and then everybody know what you do from there. You hit sine inverse, right? Because you want to find the angle. So the angle, capital B, is going to be sine inverse of 0.886327. So hit sine inverse. I'm going to use the answer key. You guys know how to use the answer key in your calculator? Right? Because the previous answer was the 0.886 whatever. I just hit sine inverse of answer equals, and I got capital B is 62. What do they want? One decimal place probably? Oh, nearest degree. So just 62 degrees. That's as close as they want me to say it. So 62 degrees for capital B. You with me on that? So far, so good. Now, when it comes to sine inverse, here comes the tricky part. You ready? There's actually two possible answers. And the other one may or may not be valid in the triangle, but there's generally two possible answers for sine inverse. What am I talking about? So before I do I'll give you the steps, but maybe I better give you, I've learned over the years, it's better just to give you the steps first. So let me just I'll give you the theory, which you really already know. I'll kind of remind you of it in a minute. But let me first just tell you what you do. So like, what am I talking about? What do you do? Well, you get, whenever you're doing the sine inverse, you get the first answer, boom, 62. And then other possible answer, and I say possible because it may or may not fit in the triangle. We'll decide that in a minute. It may make the total in the triangle too much. We'll decide in a minute. But anyway, at first, how you find the other possible answer is you take 180 minus whatever answer you just got, which is going to be 118, I think. What's that? Is that good? Yeah, 118. 170. Yeah, so 118. Now, that's another possible answer. Now, the question is that a valid answer? Could angle B up here really be 118 degrees? Look at how much we would have in that triangle. If we had an 80-degree angle and a 118, how much is that total? 190 something. Already over 180. Not possible. The only answer is 62. There's only one triangle possible. That's what they're talking about the one triangle, two triangles, three triangles thing. You can get, and I'll give you more of the theory in a minute. But for now, mechanically, stepwise, that's what you do. Whenever you do sine inverse, and you get an answer, there's actually two possible angles, and the other one may or may not be valid within the triangle. So you get the first angle, the other is 180 minus that. You get that answer, and then you put it in the triangle, and if the total is less than 180, it's okay. If the total is 180, so no, because 80, the 80 we already have, 80 plus this 118 is more than 180. Can you read all that down? Oh boy, you can't read it with the little finger thing there. Right? So the other answer I got, let me do this again. It's a big mess here. So ABC, let me just redo this real quick. I just want this clear. So angle A, angle B, angle C, they gave me 80 and then 9 and 10. So 80, 9, and 10 there, right? And then they told, and this is little a, little b, little c. And then I did the whole thing again. I did 10 over sine 80 is, right, I did these two, and I did these two, is sine of b, is 9 over sine b. And then I cross multiplied, so 10 sine b is 9 sine 80 divided by 10 and I ended up solving for inverse sine of whatever that number was. This was 0.888, oh, come on. 0.886 inverse sine, and we got 62 degrees, right? Yeah, 62. So that's that, and then we did the other possible angle. So what you always do when you're doing sine inverse is you have another possible angle. In the next section, we're going to do the law of cosines. And for cosine inverse, you do not have another possible angle. And I'll give you all the theory. You've actually seen it from the last chapter, but it might not occur to you right now why that's the case. But I'll remind you, and you'll see. So 118 is the other possible angle, but no. And the reason it's no is because 80 plus 118 is more than 180 degrees. So it's out. The other possible angle is only 62 degrees. There's only one other possible way that angle could be. There's only one possible triangle that fits the given information, that fits having an 80-degree angle across from a side of length 10 and another side that's 9. There's only one way to have a triangle like that. That other angle has to be 62. Does that make sense? And then we could find the rest, right? In other words, what else do they want? Is that all they want? No, they want C. They want everything. Okay, then they want C. You could find that easily enough, right? How could we find angle C now?
Add the two angles.
Yeah, the add and subtract from 180, and all the rest is the same. Is that okay? Once you got that information?
Yeah.
All the rest is the same. Is that good? Does that make sense? Let's do another one. Let's get used to the steps, and I'll show you the logic behind it in a little bit. Let's just do another one with. There we go. Same kind of thing. So draw yourself a triangle. Going to end up doing the sine inverse thing again. Get an answer, and then the other one is 180 minus that. Check if it fits in the triangle. I think this time it might work. I don't remember exactly. I'm going to draw it. This is number 5. Little a is 40.6. All right, we good to there? So there's the picture. There's the setup of what we have. And what are we going to do first? Oh, which angle are we going to find first on this one? Did they even say? Yeah, C. Yeah, do you see why it's C? Do you see why this is the angle we're going to find first, not B this time?
They gave the side length.
Because we have the side length across from C. We have the little c. So those go together, right? So we can't even find B right now, but we can find angle C. So we go, okay, so I'm going to go little a over sine A is little c over sine C. Right side over sine of the angle across from it. So little a is 40.6 over sine 150. These two. And these two, right? is little c, 26, over the sine of capital C. Is that good to there? We good? And then diagonal, diagonal. Diagonal, diagonal, bring it up here. So I've got 40.6 sine C is 26 sine 150. We good? And then solving that for sine C divided by 40.6. And so we've got sine of C equals whatever that is. I'm getting 0.320. You guys getting that? And then C is the sine inverse of 0.320. So sine inverse, hit the answer button on my calculator anyway. I'm getting 18.6. Do I also round the nearest degree again? Yeah, nearest degree, okay. So I'll just say 19. Mine's 18.6, so it rounds to 19 degrees. So C is 19 degrees. Good so far. Now, let's find the other possible angle. So the other possible, whenever you do sine inverse, is 180 minus that one, which is, what's that, 161? Now, is that possible in the triangle? Could this angle C be 161? No way, the other one's 150. 161 and 150 is way over 180. So again, this is no. No, because 150 plus 161 is more than 180. So that cannot be. Not possible. We're done right there. Yeah?
How come you don't add the 150 to 19 and then minus whatever we get from when adding that number to 180, minus it from 180?
Yeah, that's exactly, we will do that. Like if we wanted to go on for the rest of the problem, that would be how I would find the third side.
Okay.
Yeah, so good question. Yeah, let me answer. It's a good question. I'm sure the people are wondering that same thing. So everybody see how, so yeah, so remember 180 is the total of all three angles in any triangle, right? Now, why I'm doing the 180 minus 19, I really haven't given you the theory behind that yet. I'm going to. But for now, so let me say it this way. There's two different reasons why you do the 180 subtraction. Two different reasons. I haven't really given you the logic behind why I'm doing it to find the other angle for sine. I'll give you that in a minute. But I'm just saying you do. You do. So whenever you do sine inverse, there's actually two possible answers to sine inverse. Think back. You can already be kind of figuring out yourself. Remember when we did the unit circle on the last test, and they would give me sine in, where they would ask us the sine of some angle is whatever, a half. Well, there's two possible places, quadrant 1 and quadrant 4, right? Where sine is positive a half. There's two angles, right? So whenever you do sine inverse, there's two angles. Remember, there's almost always two answers to those inverse trig questions, right? That's why there's two answers. So that's why I'm doing the 180 minus. Again, I'll get to the details in a minute. But that's a different reason for the 180. And then when I get that answer, I see if it with the 150 is too much. If it's more than 180, forget it. So the subtracting from 180, there's two times we do that. One time for this special sine inverse thing. It's a different thing altogether. Versus once I go, okay, 19 is the other angle. This one's 19. Now I go, 150 and 19. That's 169. Subtract from 180. What's that, 11? Yeah, 11. This angle B up here must be 11 degrees. Yeah, that's the subtract from 180 to complete a triangle. That's another reason why we do the 180 subtraction. But that's different than what I'm doing right here, which is a special characteristic of sine inverse.
So you're basically like trying to match it up with the 150 by 180 minus 19?
Right, I'm seeing if it can go with the 150 or not. Yeah, you always do 180 minus it to get it. Yeah, maybe it's time to show the theory. Why? Why is that the case? Well, just think about it for a minute, guys. What if let's go back to the one I just asked. What if I said the sine of some angle is a half, for example? What angle makes that true? Well, it's the sine inverse of a half. Do you see how when we answer the question, we didn't really write it that way in the last chapter, but that's what we were doing, right? What would you do? You'd go to your unit circle, which you will have written on your 3x5 card. You find the two places where sine is a half. Anybody just know off the top of their head? What are the two places where sine's a half? Yeah, right here at 30 degrees, because it's up a small amount. Sine is how far up you are. Sine is the y-coordinate. And then up 30 here, this is 180, so this must be 150, huh? At 30 and 150, sine is positive a half, right? All students take calculus. Of course, this quadrant, they're all positive. This quadrant, sine is positive. Of course, it's going to be the first and second. Did I say first and fourth a minute ago? First and second quadrants where sine is going to be positive, isn't it? So what are those angles? 30 degrees and 150 degrees. If you hit the buttons on your calculator, if you hit sine inverse of a half, it'll only give you the 30-degree angle. You guys have your calculator? Hit it right now. Hit sine inverse of 0.5 or sine inverse of a half, either one. It'll only give you the 30-degree angle. That's all it'll give you. You guys getting that? Now why? Because 150 is true also. Sine of 150 is also a half. You can check it on your calculator. Hit sine 150. It'll be a half. So why doesn't the calculator, when you hit sine inverse of a half, give you both answers?
It doesn't always work with both answers.
Yeah, it doesn't give you two answers. Do you know what it gives you? It gives you the restricted values. Did we talk about that briefly? Yeah, we did, but I know we talked about a lot of things. The sine is restricted to these sine inverse to these two quadrants, remember? Negative 90 to positive 90. That's all your calculator is ever going to tell you, is answers in the fourth or first quadrants. That's all it's going to tell you. But really, there is another answer, as you know, 150 and 30. So now how would you, now if you had the 30, and that's all you had, how would you find the other answer? Yeah, 180 minus it, you see, you get the 150. You see that? Because it's the same angle in the second quadrant. Notice how far up this is up the same amount, which means 180 back up, whatever. Do you see that? Do you see how that gets you the same answer, same reference angle in the second quadrant? So whatever first answer you get, the second eight, right, because that's how far up this is, how far up that is, 30 degrees. Well, that's how far up this is, but you got to go 180 back up that, 180 minus that, and you get the answer in the second quadrant, which is sometimes valid in the triangle, sometimes is not. Depends on the picture. So far, we got two no-goes. That making sense? So that's why when you do sine inverse, you have to find the second one with the 180 minus. That's how you will find the second one. Cosine inverse, which we'll do in the next section, won't have that problem. We can just do it straight because probably too much information maybe, but cosine inverse is these two quadrants automatically. I don't know if you remember that. Cosine inverse is those two. So it'll automatically give you the right answer in those two quadrants. All right, it's about the restricted values. I know that's where things get a little tricky. All right, so let's go back to... All right, let's try that one. AB and capital A. So I bet we're going to get two answers that are valid in the triangle here. All right, and they want you to find capital B. So do the same thing. Set up the law of sines ratio. And diagonal, diagonal. Get to there. Divided by the 16. I'm getting 0.862. And I'm getting 59.5, so I guess that's 60 degrees. You guys get 60 degrees? So 60 degrees, that's one answer. Now the other answer, what do you always do? 180 minus it, so it's 120. The other answer is 120. Is 120 valid? Could B be 120? Yeah, that's valid because 120 and the 50, it's under 180. That's possible. So we have two possible scenarios here. That's making sense? Two possible triangles. Yes, it's possible because 50 plus 120 is 170. It's the total is under 180. So it's definitely possible. So that means there's two triangles we have to figure out. Two possible triangles. So let me explain what's happening here. Basically, the way the two triangles are, let me just go over here and draw a picture for you. The two possible triangles go like this. They're saying you've got side A, which is a certain length. What is it, 18? They say this is 18. And you've got side B, so this is fixed. You got this side, which is going to be of length 16. And there's two different ways to do it. You could do it that way, or you could swing this. Oh, wait, the bottom's 18. I'm getting confused. How? So that's 16. So that angle is either 120 or 60. But that side is 18.
A is 16. I think 18 for A.
Yeah, A is 16, right. So A is 16. So B can change. Oh, it's swinging the other side. Gotcha. No, but that would move that. Yeah, right. So that's 50. So the other angle, C, is going to get really, really tiny. Yeah, that's what's going to happen. So the other way it could go is this side could get really, really tiny. And this angle get really big. So this is still 18. This is still 16. And this is still 50 here. 50, 50. They both have all those the same. And the top is either 120 or 60. So the top is either 60, or in this case, it's 120. It's a really big angle. That's the other possible triangles. Everybody see that? This will only be 10 degrees. Whereas this one will be what? 110, 70. Everybody see those two possible? They have all the same given facts. Although some other to-be-discovered facts are different. Everybody see that? They're both triangles that have the 50 angle, the 16, the 18. It's just the other angle's huge, 120, or it's just 60. Makes two different looking triangles. They're both possible given the initial facts. So we have to solve both those triangles. Everybody see how I found the third angles? Right, I just subtracted from 180. That's how I found the 10 and the 70. Right, because I had the 50 and the 60, which is 110, so the other angle's got to be 70. And here I had the 120 and the 50 is 170, so then the other angle's got to be 10. Everybody tracking with me? We doing okay? This is exactly what they're going to ask us to figure out. They're going to say, okay, if there's two possible, right? 60 in one case, 120 in the other. They're both possible. Go ahead and complete both triangles. So now I'd have to find the missing side here, this little c. So how do I find that? Little c over the sine of 70 is whatever two you want to connect, say like these two. 18, the side first. 18 over the sine of 60. Solve that diagonal, diagonal. C sine 60 is 18 sine 70. Divide by sine 60. Little c equals, let's get an answer there, 18 sine 70 divided by sine 60. I'm getting 19.5. I don't know how accurate do they want? Oh, they just want the angles. They don't even want the sides, huh? Oh, we're done then. They just want the angles. All right, we're done. They don't even want this. They just want the 60 and the 70, the 120 and the 10. That's all they want. No?
There were others.
Oh, we're there? Am I? Yeah, so they do want the C. Oh, and how much actually? Did you notice? And then in this case, let's find the C over here in this case. The C would be what? C over sine of 10 is 18. I always want to do that 120 first. 18 over the sine of 120. So I'm doing both triangles. You guys with me? Am I losing you? Am I doing the Charlie Brown teacher? Wah, wah, wah up here? Does this making any sense? Everybody see how we got here? How did we get to this crazy point? We came back here. We did the same thing we always did. When we hit sine inverse and got 60 and then subtracted from 180, the other 120 was possible. It worked. So I set up two triangles, one of them with the 60, one of them with the 120. Right? And then I found the third angle in each case by subtracting from 180. And now I'm finishing up finding the last side in each triangle. So the last side, side C, we get C sine 120 is 18 sine 10. Last step, divide by the sine 120. Boom. C equals whatever that is there. Sine 10 divided by sine 120. I'm getting 3.6. 3.6. In this other case, it's 19, a lot bigger, 19.5. Here it's tiny. As we can see from the picture, it looks tiny. 19.5, here it's much bigger, huh? See the different look of the two triangles? But both triangles fit the initial conditions, don't they? Both are possible triangles, given those initial conditions. So sometimes initial conditions limit you to one triangle. Sometimes initial conditions allow two possible triangles, don't they? That's what we're saying. Let's go back and put these in. So 19.5 and 3.6. Is everybody good with that? That makes sense? All of this is correct. Questions I can answer on that? Two possible triangles. Now there's a third case, no possible triangle. We'll see that one next, I'm sure. So you can get two triangles possible, one triangle possible, or really they could be make-believing the initial conditions, and there's no such triangle that really fits that reality. We will see that. Okay. Okay, so there we go. Let's try it again. A is 10.9, B is 33, capital A is 28. Try the same thing again. And you'll know if you hit sine inverse and you get error, that's how you'll know there's no possible triangle. It's when you hit sine inverse. Wendy?
Math Excel had a formula that you can go through that can tell you off the bat how many there's going to be multiple solutions or it doesn't work.
What was their formula?
Is H equals
Maybe I should click that. Yeah, it's easy. Doesn't that happen in math test? That happened to me sometimes. I would look at the test, they kind of all look alike. That's what you want to practice for a test is I didn't notice this word at first. Area. We haven't been finding area up to now. Area means space in the middle, right? Like how much space is in there, right? You with me? We're not just talking about side length and angle measurements now. We're talking about space in the middle. How much space is in there? How much area? So how do we do area of a triangle? Does anybody know?
Is it half base times height?
Yeah, remember that? Remember the area of a triangle. You guys remember that from your algebra days? Half base times height? Remember that area formula? Guys remember that one?
Yeah.
From now that's I'm going to derive. I never get a chance to derive anything. Let me derive this one with you. Let me come up with the formula they're going to use. They're not going to use this. They're going to use another special formula. But let me show you basically here's what they're going to use. You can take a half times any side times any other side times the sine of the angle you're not using. And that will be the area of a triangle. Now, why? Well, let me show you. We can derive. It's really very easy. So it's a half times base times height, right? That's the area of interest. Let's draw a triangle. Okay, let's say this is A, B, C. This is little a, little b, little c. Did this just with my daughter about a week ago. She saw it in some book, and she said, "Oh, they want me to use some fancy formula." And I showed her, "See, it's just this." Boom. She's like, "Oh, that's not bad." So it looks all impressive when they write it down like that. But let me show you. It's really easy where it comes from. So okay, so now I want to put height in there, right? Because we're saying the area of a triangle is a half times base times height. That's the area of a triangle. Half times base times height. Now, where's the base and the height on this triangle? I don't see a height. Well, you know what height is. We just talked about it. What is height? Straight down to the ground, to the base. So now really you could go to any side. Like I could go to this side at a right angle, and that's just turn it, same thing. So you could pick any of the three sides to be the ground, the base, really, any of the three, and then just draw straight to that ground. It'll work. So I could turn this triangle. So I'll just use whatever's on the ground as the ground. Straight down. So this is height, right? So the area of that triangle is a half times the base, which is B, times the height, which is H. That's true. That is, we already know that formula, right? That's something you already know. That's true. But how do I get that H? Well, I just showed you, huh? How do you get H? This is an angle A. How do you get H? The sine of angle A. Now, for the moment, I'm ignoring this. And I know it's there, but I'm focusing on just the right triangle inside of the original triangle. I'm just looking at that right now, right? Because SOHCAHTOA is only true for right triangles. I don't know if that's ever hit you before. SOHCAHTOA, write it up here. SOHCAHTOA, what we use all the time is only for right triangle. You got to have a 90-degree angle in there, or you can't be using SOHCAHTOA. So they just give you a normal triangle with no 90-degree angle. SOHCAHTOA doesn't hold. SOHCAHTOA, well, how do you know? Well, because it has an H. What's the H stand for in SOHCAHTOA? What do those H's stand for? Hypotenuse. What's a hypotenuse? Across from a right angle, right? You got to have a right angle, or SOHCAHTOA doesn't hold. So SOHCAHTOA is only for right triangles. So I put a 90-degree angle in there, the height, and I go, okay, the sine of A is opposite over hypotenuse, H over C, right? Solve for H, right? Multiply both sides by the C. You guys with me on that? Multiply by C, cancels. H is C sine A. So now I know what H is. It's C sine A. So now take that C sine A and pop it right in there for H. You see that? So what's the area equal? A half times B times what? C sine A. Is that getting too small? There's the formula. A half times two sides times the sine of the other angle. There's how they came up with that formula. Do you see that? Anyway, you don't have to do that. That was extra credit, fun. Was it fun? Did you enjoy that? I just need to do that every now and then. So math doesn't look like magic. Math is not magic. There's logical rules for all the little things we have. So there it is. There's how they came out. So anyway, let me give you the formula now. So the area, now that we have that, here's what we're going to use. The area of a triangle is a half times any two sides. So you could go AB sine capital C, or you could go BC sine capital A, or you could go, what are the other two? We got AB, BC, AC, huh? Sine capital B. Any of those are right. Does that make sense? It's a half times 2 sides times the sine of the other angle, which is between them, really. That other angle is between them. Any of those will work. So, then, on this problem, what do they ask me? They're giving me B is 48, and they're giving me A and C is 5 and 7. So capital B, what number is this? Number 8. So number 8, I already forgot. Capital B is 48, 5, and 7. Okay. 48, 5, and 7, right? Yeah. All right, so they give me that information. They want the area. What's the area? Well, it's going to be little a times little c times the sine of the other angle. So you use all three, don't you? The 2 sides and the sine of the other angle. Oh, and the half. Don't forget the half. So half times 5 times 7 times the sine of the 48. And then hit the buttons on the calculator. So it's 13.005. I don't know how much accuracy they want. Is that good? So it's a new way of finding the area of a triangle using the sine. That's what it is. So using the sine, it's a way to find the area of a triangle. In the ABC here, here's A, B, and C. Here's little a, little b, little c. So notice that they gave me little a is 5, little c is 7, and capital B is 48. See how it's the 2 sides and the angle in between them? That's what it is. It's the 2 sides and the angle in between. You can use this formula, any of these formulas, for finding the area of the triangle. And it all just came from a half base times height. Is that good?
So it wouldn't work if they gave you side B, but also angle B.
Right, we'd have to do some other stuff. You're right. All right, so there we go. They want this, call this x or whatever. They want this distance here. They want x. Can you do that? Let me give you a minute. I think you get more out of it than if I just start whipping it out. So try that. Let me give you a second. And that x. These two go together, don't they? So we could say like x over sine 54.7. 84? It's 84. Kind of scribbling it up, huh? 84.7. So x over sine 84.7. Those two go together. But what other? I need another pair. Like I also either need b and the side angle across from him. I don't have b. So that's not going to help. Right? I can't go b. You understand my problem? Let me write it down. Maybe you'll see it better. That is not going to work because there's 2 things I don't know. I don't know x or b. You've got to have only one letter, right? Only one unknown. You can't have 2. How am I going to solve that? Right? That's not going to work. So I can't do the b side. Well, can I? So I can't do those 2. Can I? What's the other 2? Can I do these 2?
Yeah.
159 and the sine of c, but I don't have c either. That's 2 unknowns. But I can get c by the 180 subtraction, right? So that's the pair I want to use. You guys tracking with me? So you got to find c first. So to find c, you got 84.7 and 52.2, which is 137.9. Is that right? 136. Is it 6? Help me out here. You have the calculators, right? And then subtract, and subtract from 180. 180 minus 136.9. And what is it, 42.1? 43.1? I'm getting 43.1. 43.1. So we got that. Stick that in. That's C. So we have got x over sine of 84.7 degrees is 159 over sine of 43.1 degrees. Now we can solve for x. That good? Diagonal, diagonal. And last step, divide by sine of 43.1 degrees. Boom. X equals 231.7. I don't know how far they want me to round. Is that what you guys got? We found out how far it is up to there. Questions on that? I think we're about ready to wrap this section up. They have a lot to say. The figure shows a shot put ring. The shot is tossed from A to B. Using modern electronic equipment, the distance of the toss can be measured without the use of measuring tapes. When the shot lands at B, an electronic transmitter placed at B sends a signal to a device in the official's booth above the track. The device determines the angles at B and C. At a track meet, the distance from the official's booth to the shot put ring is 545 feet. Okay. If B is 84.3 degrees and C is 5.4, determine the length of the toss to the nearest foot. So, long story short, they want C. It's a lot of words. They want to know how far C is, right? How far the toss is. So that's the same thing, right? We got two angles, so we can find the third angle. Then we have all three angles. Then we can do the law of sines. Okay? I just go dot, 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 like that. All right. Let's start. We have a half an hour.